Good afternoon. My name is Alex Moffat, and this is Damon, Lundin. And we're going to talk about our experiences building Lombardi Blueprint with GWT, or GWT, as I should now pronounce it. So this presentation includes some examples, and you can download the code for the examples from our blog, development.lombardi.com, so you can actually run them and don't have to worry about trying to read a couple of lines of 18-point type and make up the rest of it. So a very quick slide that Damon is going to talk to. But before we get to that, who here has got GWT code running in production at the moment? And who's experimented with GWT? Wow. Great, thanks so much. So quickly, please.
Okay, so I guess I'm going to go through this very quickly. We weren't sure what the level of experience was going to be. But basically, as I think pretty much everyone in the room knows, that GWT is a toolkit that allows you to create a JavaScript application written in Java. The obvious advantages are you can use all your favorite Java tools, like your development environments, your debugging tools, your testing tools, things like that. Handle some of the differences between different browsers. You still need to know some things. GWT can't cover over everything, but there are some differences that it can take care of. One of the things that you may not be aware of that is one of my favorite features is the optimization of the GWT compiler. The GWT compiler is capable of doing optimizations like method inlining, string interning, and a whole host of other things that you wouldn't normally do if you were writing your JavaScript application by hand. So even if you were writing your application by hand, you're still not likely to produce code that is as efficient as what comes out of the GWT compiler. For those of you who are experimenting with GWT or have an existing JavaScript application, I also want to make the point that you don't need to worry about trying to use GWT with that existing code. GWT can integrate with existing JavaScript libraries or code, and it can peacefully coexist with that code. The application that we're going to show you here today was originally written in JavaScript using the Dojo toolkit, and when we decided to use GWT, all of our new features were implemented using GWT, and over a period of time, we slowly migrated the existing code, the existing JavaScript code we had, into GWT code. It was not something that we had to do all at once. So I think that's an important point to make. So Alex is now going to show you what we've done with GWT.
Right, and what I want to talk about really, what I'm going to try and show is the UI more than any particular features. So this is the home page for Lombardi Blueprint. We have a list of what's happened today, and I'm going to look at a particular project and then look at a map of a process within that project. So this is basically the outline for what you would do if you wanted to give a talk. So at the moment, I've got some sorts of things I'm thinking about, like I need slides, I need to do an abstract, I probably need to rehearse. We got some travel I got here. Now I can do things like the abstract should probably be before the slides. Let's make the slides actually part of that. Let's do hotel and travel, and then I need to submit this thing. So we've got here is basically drag and drop. This is all JavaScript. I can move things around. Stuff rearranges. We've got some animation. Panels fly in and out. Different views appear. It's all fairly fancy. It's all done in GWT and HTML. We've got things like expanding and collapsing panels. And I just want to point out this bit down here at the bottom because we're going to come to this later. So what I want you to get out of this is this is the sort of look that we have for an application. It's not like an Eclipse style. I have a tree on the left and a bunch of forms in an area on the right. Because what I actually want to talk about is how we do UI development for that sort of UI. How do we go about building that sort of thing? And the first, probably most important point is that really it's based on a foundation of everybody in the team really has to feel that it's a big part of their job, the most important part of their job, to create a great user experience. Because Blueprint is really all about the user experience. People have really got to enjoy using this tool, because otherwise they can just cancel their subscription and stop using it. It's much more of a voluntary sort of thing than apps that you're going to force hundreds of people across your organization to use. We have 2 user experience user interface designers working on Blueprint. And they take the market requirements from product management and are responsible for producing the visual realization of those. So how are we actually going to present these features to the end user? And of course, it starts with a whiteboard. So you work out, what assumptions are we going to make? What are the use cases? What are the various process states? Let's draw some things on pieces of paper and stick them on the wall and annotate them with sticky notes. And then move on to the next stage of producing some quick mock-ups, some wireframing in Illustrator. And at this point also, you can go out to users and potential users and test the interface as it is now. Are the features readily discoverable? Does this actually present in a reasonable way? And this is also a point where the programmers can say, that feature there is really going to be incredibly difficult for us to implement. Can you think of another way to present it? Just as important is mocking up the interaction. And this is partially still an open question for us. We've used PowerPoint or Keynote to present the flow. So, I click on this button here. I'm going to switch to another slide showing the next screen. We're investigating a tool called iPlots that is an online way of presenting demos. But it is important to be able to mock the interaction up cheaply at an early stage rather than require everyone to write the GWT code and then say, I want this panel to slide in instead of slide up because that's going to change the way in which we do our layout. Then the final stage of this, of course, is the high-fidelity mock-up. These are more expensive to produce because it takes them more time to do it, and these are done in Photoshop. At this point, again, we're testing, is this the right color choice? Is this the right look? And also, it's great documentation when you're programming, if correctly annotated, with what are the font choices, what are the colors that are involved here. The UI people also give us all of the assets that we need, so all the nice rounded corner bits, all of the icons, all the colors, everything like that. The big question, especially for me and Damon, is when you're faced with a Photoshop mockup like that, how do you go about converting that into actual running code? And our first one is you have to be involved in the design, because you don't want to end up with something that you're not able to implement. The converse, and that I really also ought to emphasize, is we've certainly been strongly asked to implement stuff that we thought wasn't possible, that we were actually able to do. The designers are acting as advocates for a great user experience, and it's very important if they consider something to be important or vital, that we make our best possible effort to do it and don't just say, well, rounded corners are a pain, let's just make it all square boxes. Rounded corners are a pain. So the other point, you need to know CSS and the HTML DOM. You need to know what your toolkit is. And unfortunately, at the moment, there's no way of getting around the fact that because you're building for a browser, you have to understand HTML and you have to understand CSS. Because fundamentally, it comes down to what is the appropriate DOM structure that you're going to build with your code, and how am I going to use GWT to create that structure and manipulate it. While GWT is going to remove your browser-specific JavaScript and DOM issues, you still have to deal with cross-browser CSS issues, and you still have to deal with browser quirks. I mean, things like the peekaboo bug and various other stuff that Damon could name off the top of his head that just cause you enormous pain when you get it working first in Firefox and it doesn't work in IE6. As an example, I'm going to go through how we construct basically something that looks very much like this panel here at the bottom. And this is the actual example that you can download in its final state. We've got a little add button that you click, so we're adding these rows with a bit of animation. We have a nice rounded, ended highlight thing. And again, you click the X and it's removed with a bit of animation. So I quite like it. I think that looks okay. Go ahead and build that. And I'm going to start with the header. Now, as I get into this, you will see that what I am talking about doing is not what was described as the fastest way to do it in the previous talk that I just watched. So I'm going to talk about nesting a bunch of GWT widgets to get my layout to look right. And if I was going to do it fast, I should probably use an HTML panel with a lot of divs. But I don't. We spend our, because we're not building a toolkit, we spend our time optimizing the bits that are going to be slow. And a lot of the time, if it's fast enough, it's good enough for us. We will also do things like, we're going to build the specific case that we're interested in, because we don't have to build a generalized layout system or a generalized system for supporting any sort of header. So in this case here, what's the easiest way to do this? I'm going to have an outer div surrounding all my content. So I'm going to use a flow panel for that. That's nice. I can use 2 flow panels inside that. And I can use CSS to make sure that I get the right-hand side to float to the right and the left-hand side to float to the left. I can use a GWT button for the add button. And then I can use 2 labels to get me the top and the bottom. And when I put them inside the flow panel, they're going to stack vertically nicely. And I'm actually going to get the behavior I want. I'm going to get the resize behavior I want without any effort. So all I do is I go ahead and I create my 2 labels. I'm building from the inside out. I create my 2 labels, create the left-hand side, set the style, add the 2 labels, create the button, create the right-hand side, create the final header, and put both of them in there. I don't bother creating a special header widget that extends composite and wrap all this together, because I'm just doing the specific header that I want right now. And again, this is going to be slower than doing it with HTML panel and divs, but on the other hand, you probably wouldn't be able to tell in our app. The next one is, now as we're moving out, we've got this outer panel here, which is this thing with rounded corners. And there are lots of different ways of doing rounded corners, and we have probably tried every single one of them. From, sliding doors to single width, single height divs, to something that Damon invented that has things absolutely positioned in the left and right. The easiest way to do this one is the 9-cell table, of course. So I can stick the content in the center, and I can use background images to get the look that I want. And the great thing about this is GWT provides you a decorator panel that makes it dead easy. And here's a case where I'm going to go ahead and actually create a widget of my own to do it. I'm using composite because I don't want to expose any methods that I'm not actually going to use, particularly because I'm building a very specific case here where I pass the header and the content in when I construct it. So I don't want to have to support a use case where someone says, well, I want to remove the content and add something else later on. And then here's the 2 bits of CSS that are going to give me the top left and the top center images. The point about this is really those 2 classes, top left and top center, are set on the DOM structure created by the GWT decorator panel, So how do you know what classes are actually available for you in the styling? You can look at the documentation, but what we've tended to do is to knock up a quick example and then use Firebug or the IE Developer Toolkit and go in and see what's the actual structure of what you've got. This is another one which is in contradiction of what we have been told previously. Handling window resizing. So how do we handle window resizing? What you want to do, of course, is you want to use HTML and CSS. You want to build it so that the browser handles the resizing automatically. The problem is the content in the center cell of that example does not work like that. Or at least I couldn't get it to work like that across all the browsers. So with static HTML, I'm doomed. With GWT, I can do programmatic layout, and we do programmatic layout. If you look at Blueprint, we do quite a bit of programmatic layout in various places when panels are removed or added. And from seeing the GWT 2.0 talk this morning, we are looking forward to panels that do all of that automatically for us. At the moment, what we do is we listen to the resize event from the window, calculate the child size, and propagate it down. What we haven't done, though, is build something like grid bag layout for anyone who's worked on Swing. We haven't built grid bag layout. We haven't built a general layout manager that takes anything, configurable sizes and stuff like that. We program specifically for what is the layout behavior of this particular thing that we want. And there is actually one extra wrinkle. Decorator panel doesn't support having a widget in the header as it's currently built. And if you read that blog post, you can see the very small change that I had to do to actually support that. If I move on to the list and the row, this is very similar to the header. So I use a flow panel to create the list, and I vertically stack a bunch of divs to form the rows. And each of those rows is made up of a number of sections which float to the left and the right appropriately. Now, of course, when you're floating the stuff to the right in IE6, you have to add it in the opposite order, or else it doesn't float correctly, which you only discover when you get to IE6 after you've written it on Firefox. The more interesting potentially point of that is rounded corners. Rounded corners highlight is quite nice, and the designer said we really want the rounded corner highlight. And in this case, because we're prepared to accept a fixed height row, I don't have to go for a fancy multi-cell table solution that will handle rows of different heights. I just say we're going to have like a 46 pixel or whatever it is high row, and that lets me just use background images and CSS styles to do the whole thing. So I create a mouse handler for the mouse over event, and because I'm past this, I can get hold of the source of the event, I can get hold of the row, and just call a mouse over method on that and add a focused style to it. The mouse out does the opposite thing, takes away the focus style, and it's simply a case of saying, inside my row, on my right end cap, it's normally white. When the row also has the focused style, I'm going to give it a background URL, a background image, and that works very nicely. The final thing I want to talk about is animation. For animation, you've got to use JavaScript, and therefore you've got to use GWT. There's no real, certainly for the browsers we support, there's no CSS3 support right now. The majority of our customers use IE6. So though it was nice to see all those HTML5 features this morning, until someone can find a way to automatically update all those IE6 browsers to something else, we are still writing to a really low, lowest common denominator. A little animation goes a long way. Don't overdo it. We've overdone it in some cases and then had to take it out again. But it really does help users understand the behavior. So, if you click the delete button, and then the row suddenly disappears, and then the row above moves into its space, and it doesn't look, especially if you've scrolled off the bottom of the screen, like anything has actually happened apart from the name has changed. A bit of animation can help you understand what's actually going on. And generally, you're going to change the size, the position, or the opacity of elements. And to do the fading in and out, I'm going to use the GWT animation class and create a subclass of that. And I'm going to override the onUpdate method, because that's the only thing I actually need. This is basically what I've got. I had my row class previously. I create a fading row, which is going to use my new FadeIn Animation, which is a subclass of animation. So when I add the row, I just add it as normal to my list panel, to my flow panel. Then I call the FadeIn method. FadeIn creates me a new animation, which I tell to execute, and it's going to run for 3/4 of a second. And my FadeIn animation is going to extend animation, and all it does is set the opacity. Now, this DOM helper class is an example of deferred binding, because, of course, setting opacity, the way you do that varies across browsers. Particularly IE6, you've got to use filters. So this DOM helper has multiple implementations that are chosen at compile time in order to get the right effect. So that was really the UI portion of it, really an infinite amount of taking pains and really concentrating hard on trying to get a great user experience. Damon's going to talk more about how to get it to work quickly.
Okay, I'm going to shift gears a little bit and talk about some of the performance challenges that we've had and how you go about building a highly performant and complex application. Before I begin, I want to show one of the most performance-intensive parts of our product. Here's the process that Alex has been working on. He's been showing you what we call our map view, which is a very simplified view of a business process that a user may be creating. In addition to this, we have another view on the same data that we call our process diagram. So we switch over here, and this allows us to build. This allows the user to build out more detail into their process than they could before. So let's say we've submitted a talk. We can insert a decision here, and we can say, was the talk accepted? Oops. Yes, thank you. If no, then perhaps we reevaluate. And then we go back and maybe want to try again next year. We can also insert swim lanes, which represent a person that's performing a particular action. So let's add one for Alex and myself. And then we can simply assign tasks by dragging these items into different swim lanes. I'm just going to make a bit of a mess here to show you some of the more interesting things that we can do. We can add sub-processes, expandable and collapsible sub-processes, so the users can decide what level of detail they want to see in their particular process. Now, for those of you who are thinking to yourself that we've reinvented Visio on the web, I want to point out that there's a very important distinction here, and that is, as you saw me editing this process here, I didn't have to worry about where I was putting these items and how I was drawing the lines. Blueprint basically did all that work for me. Blueprint has built into it a very sophisticated positioning and routing algorithm. And this helps the user resist the temptation to spend hours fiddling with where exactly all their boxes go and how to get all those little kinks out of their lines. But because of that, it means that we have this computationally intensive algorithm that sucks up a lot of CPU cycles. And so that makes it very difficult for us to spend a lot of time doing other things. Unfortunately for us, we also have another significant constraint, and that is most of our customers are corporate business users who have little or no control over their own machines. They can't install software, they can't install plugins. We're basically limited to what those users have. And despite all of the tears of frustration that we have, most of them are still using IE6. And unfortunately, because of that, it means we have to write an application that will work even under IE6. And IE6 is, in fact, what we're using here for this demo. Let me insert a link to a larger process, aptly called large process. And let's open this up. So I'm going to open up a larger, more complex process to show you a better idea of scale and the types of things that we can do in this application. Every time the user reviews a process, or every time we make a change, when I added a new item, or I drew a new line, or I expanded or collapsed a sub-process, this algorithm in Blueprint is generating the entire layout every time. And that's something that we need to do pretty quickly. And so let's zoom out here and take a look at what we've got here. So this is something that Blueprint generated the entire layout for this when I opened this particular process. So let's talk about how exactly we did this. Well, the implementation that you see here is not the first implementation of this that we did. The original implementation we did is done in a pattern that's probably very familiar to a lot of you, in which I have some example code up here. It's pretty traditional. This is traditional GWT code, something you might see in Swing or Eclipse or any other UI-based framework, and it looks like this. In our case, we're going to iterate over all of these items that we want to display on our diagram, and we're going to create a widget to represent each one of those items. Now, these widgets are not simple objects. They're complex objects. They have other widgets, flow panels, text areas, images, and other things like that nested inside of them. In addition, we're going to want to create keyboard and mouse handlers because we want to be able to respond to user actions. So we create handlers, and we attach those to our widgets. And then once we've got our widget, we add it to a root panel, and it becomes part of our application. Well, unfortunately, this breaks down at some level. One of the most expensive things that you can do in JavaScript is object creation and garbage collection, particularly in IE6. Now, this is something that has gotten much better with every version of the new browsers that come out, but if you're still having to program against IE6, this is going to be one of your biggest problems. Every time I create one of those widgets, as well as all of those nested widgets inside, every image, every text box, each time you do that, GWT is constructing a JavaScript object. So if you have a lot of widgets, especially a lot of complex widgets, you're creating a lot of objects. It could be hundreds, thousands, or even tens of thousands of objects. If you're doing that, you're going to find that your application behaves very slow. In addition, we're creating a JavaScript object for every one of those handlers. That's, again, a whole bunch of JavaScript objects that we're creating. Once we create those, we're having to attach them to every one of those widgets. Now, before any of you think I'm dissing GWT here, I want to point out that this pattern that I've just been talking about is what we use for almost our entire application. The things that Alex just showed, the map that he did the demo of, uses that pattern. It works most of the time. But it breaks down when the scale increases. It doesn't scale, as it did in the case of our diagram, especially where we have this computationally expensive algorithm. We can't spend a lot of time creating JavaScript objects. So how did we deal with that? Well, when we looked at coming up with another implementation, the most important thing to us was to make sure that we improve the responsiveness of the application. We wanted to make sure that when the user opens a process or they make a change to one of their processes and we have to generate a new layout for it, we want to get that result to the user and show it to them as quickly as possible. Well, the fastest way to do that is to unfortunately regress to an earlier style of programming and revert to generating raw HTML instead of creating all those widgets. In addition, instead of creating handlers and attaching handlers to all of our widgets, we're going to use flyweight handlers. We'll have one instance for every type of item instead of every widget. In our case, we have 12 different types of item. That's a fixed number. In our case, we'll have 24, so one for rendering and one for event handling. And then instead of attaching handlers to every one of our widgets, we're going to attach a handler at one location on the diagram. And let's go through these in a little more detail. So here we have how we do our rendering. So this may look familiar to you. This probably looks like servlet code. But I want to remind you, this is not servlet code. This is code running in GWT, in JavaScript, on the client. We start off by creating a string buffer. And then just as we did before, we're going to iterate over all of the items that we want to display in our diagram. And we're going to request one of these flyweight renderers that we have to generate the HTML for that particular item. And you can see that down here at the bottom. We simply append a bunch of HTML to our string buffer. We add the dynamic elements to it, such as the ID, its position, any other that information that belongs to that layout. Once we have the HTML for our entire diagram, we simply call this set inner HTML, and it inserts all of that HTML into the DOM all at once. This is the fastest way to generate dynamic content on the client. When I was preparing for this talk, I went back and I looked through some of the prototyping that we did for this, and some of the numbers we saw, you could get up to 12 times improvement by doing this versus having very complex widgets. Now let's talk about event handling. So here we've got some example HTML. This is what sort of a snippet of the HTML that we might have produced from this rendering that we just had. In this case, we've got 2 items represented by those 2 divs up there at the top. And let's see what happens when a user clicks on one of these elements. What happens is the user generates an event at that innermost element that the user clicked on, in this case, that innermost div. The browser is going to take that element, that event, and bubble it up through the HTML hierarchy until it gets to the top. And this is where we're going to put that single listener I mentioned before, which looks like this. So here we have this diagram class, and the first thing we're doing is we're calling this sync events method. What this does is it enables this class to listen for events on this particular element. Now before, we were creating handlers for every one of our widgets, and we were attaching those handlers to every one of those widgets. Now, with a single call, with one line of code, I've enabled handling for our entire diagram. Every time an event occurs anywhere within your diagram, this method on browser event gets called. Fortunately, the browser tells us what exactly it was that the user clicked on from this get event target method. That's going to be that innermost div that I mentioned before. Now, we don't really want to know what the innermost element was. We want to know what that div sort of at the top was, the div that represents that top of that item. So what we do is we simply walk backwards up the hierarchy until we find an element that has an ID attribute on it. Once we've found that, we know we've gotten to the top, and now we know what item it was that the user clicked on, and we know its ID. Once we know the item that the user clicked on, we can look up its type, and then we can forward this call to a handler for that specific type. And then we can allow a handler to handle that event, that item in a way that's specific to that particular type of item, whatever it was. Now, this works in simple cases, such as mouse over. Let's say you want to highlight a bunch of items as you're moving the mouse across the screen. Well, when you're doing that, all you need to know is what element it was that the user moved their mouse over. But let's say, like, instead of mouse over, the user has clicked on an item and they're now dragging it across the screen. What we want to know, not just what element it was that the user is dragging, but we want to know what other elements are underneath of it, or what elements may be near it, because we want to find possible drop targets. Well, at this point, all we have is a bunch of HTML that we've generated. Really what we need is we need some more useful data structures. We want to be able to organize some data structures into perhaps bounding boxes or something else that's interesting so I don't have to search the entire diagram. We really want to get back some of what we lost when we had those widgets before. Previously, we could ask the widgets, are you a possible drop target? And they can answer that. And unfortunately, we don't have those anymore. One thing I want to go back to is that number one goal that we had before, which was we wanted to make sure that when the user makes a change, we want to show that response to them as quickly as possible. Setting up these interesting data structures is not necessary to doing that. So we want to make sure that when we generate this HTML, that we get that to the user immediately. And only after that do we want to spend any time that we need to set up these data structures. And that's how this is how that works. So we start off here. We've got all of the HTML that we've generated from our layout code. We've inserted into the DOM. The next thing we do is we execute a deferred command. And what this does is it gives the browser the opportunity to actually render that HTML and show it to the user. When the browser is finished doing that, it will call this deferred command and execute this create cache function. That cache function will basically iterate over the DOM. All the information that we need, where things are positioned and how exactly things are laid out, is encoded right there in the DOM. So all we're going to do is we're going to parse that information back out. So here we get the element from one of our items. We parse out its ID, its position, and then we can do whatever we want with that data structure. We can arrange them in any interesting way so that we can do event handling in the future. Okay, now let's say that you've done all of these things. You're down to raw HTML, you're down to single listeners, and you're finding that things still are a little slow. Maybe you've got an application where under certain conditions things get too complicated and your application really can't execute quickly enough. Well, there's one thing that is unique to GWT, and that is you can compile your code into both Java bytecode and into JavaScript. Then your application can decide at runtime whether or not to execute that piece of code on the client or on the server. You're going to find that in many cases, the Java VM is much faster than the JavaScript engines, particularly those in IE6. Now, again, those keep getting better in every generation, but if you're still working with an older browser, you're going to find that the Java VM really is much faster. So now we get to the point where we want to decide, do I execute this particular piece of code on the client or do I execute it on the server? Well, we argued over a number of different options. Try and predict how fast each one's going to take, try and measure or estimate network bandwidth or latency. But we decided in the end that the simplest algorithm was the best. And the way that works is every time the user opens a process, for the first time, we're going to go ahead and we're just going to do that on the client. Now, that could potentially be slow, but we're only going to do that the first time. If that's not slow, if the user's using a modern browser that's quick or they're working on a small process, then we can continue to generate those layout on the client. That'll give them the most consistent and most responsive interaction with our application. But if it turns out it's not fast, if it's under a certain threshold, in our case 2 seconds, what's going to happen is the next time we do a layout, we're going to execute it on the server instead. When we do that, we're going to measure the entire round trip. We're going to send a request to the server, and measure how long it takes to send that and get a response back. Once we've done that, we know how fast the server is, and we know how fast the client is, and from there on out, we can simply pick whichever the two of those is fastest. We also keep a running average, so if for some reason one of those starts to get slow over the other, we can actually just dynamically switch back and forth. For us, the way that we do it is we use a GWT RPC call. The interface is actually very simple. We make an RPC call. We simply ask the server, generate a layout for this particular process, and it pretty much just sends us a string with a bunch of HTML back in it. Now, because of that create cache function I showed you a minute ago, the client already has the ability to parse that information, the layout information that it needs, right out of that HTML. And so I actually wanted to give a quick demo to show how exactly this works. So I'm going to add a little debug parameter up here on our URL to show us what's happening. Now, when I've changed the URL, it's basically causing this process to reload. So this is as if the user is coming into this process for the first time. And as I said before, we're going to generate a client-side layout. I don't know if you can all see that, but that says client layout 4,047 milliseconds. That's obviously longer than that 2-second threshold we had. So if I make a change to this process, the next layout should occur on the server. Server layout, 797 milliseconds. So this is about 5 times faster. So I can hit undo, 688 milliseconds. So as you can see, in one case the client is slow, but then we figure that out and we start executing the next operations on the server. Now, there's one interesting point about this, which is this demonstration right here actually gets less impressive every year. And that's because the client actually is getting faster. And I think this is a good testament to using GWT and a good argument for why you should use it. Every time a new version of GWT is released, our application gets faster. We originally did this test on 1.3. When we upgraded on 1.4, when we upgraded to 1.5, we saw about a 10% improvement sort of in general across our entire application. And that's part of the reason why I've done this demo before, and instead of 5x, we've seen 9x difference between the client and the server. So as the client gets faster, this becomes less important. I've done a couple of tests with 1.6, which we haven't upgraded to in production yet. We haven't seen a general performance improvement for that, but for 3 of the processes where I did a test for our layout portion of it, 2 of them were 33% faster, and 1 of them was 150% faster. And we didn't have to do anything. All we had to do was upgrade the version of GWT that we're using. And then finally, to wrap up, we have just a couple of slides that are just sort of a bunch of random tidbits that we have. They're sort of just random thoughts that we thought were useful. I don't know those of you who were at Bruce's talk this morning, but he mentioned the fact that compiling GWT code is very slow. For those of you that started with 1.4 earlier, you'll know that when 1.5 came out, it got a lot slower. Now, it's worth it given all the optimizations that the compiler does, but sometimes it can be very painful. By default, when you ask GWT to compile your Java into JavaScript, it's going to do that for 5 different browsers. Now, when you are actively working on development, you don't usually need to be doing that. Usually you're actively debugging and working on only a single browser at a time. Well, a very useful trick is that you can actually tell GWT to only compile for a single browser, or a single locale, or a single permutation. So this is one of our GWT module XML files. We simply have a line in here that we keep commented out. And when I'm doing debugging and I want to only build for, in this case, Internet Explorer, I simply uncomment that line. And next time I do a compile, it's only going to generate the JavaScript for Internet Explorer. You're going to find that this saves you a lot of time.
Hosted mode is the better choice.
Yes. Yes, if you're using hosted mode, well,
of course I'm on a Mac, so I can't use hosted mode to do IE6, which is why I want GWT 2.0.
Yes. Yeah, the main advantage of hosted mode is obviously you don't have to compile at all. You simply launch hosted mode, and it compiles on the fly. You make a change, you simply hit refresh, and that happens very quickly. This will probably actually become completely unnecessary when GWT 2.0 comes out and they release the out-of-process hosted mode, in which case you're almost never going to need to actually compile, do a GWT compile. A similar tip that you can use for this is that if you have an application that's particularly large, you can also consider splitting it into multiple modules. So in the case of Blueprint, we have a home page module, we have a process page module, an admin page module. When I'm doing development, I'm likely only working on one of those at a time. So if I make changes to a particular piece of code, I only recompile that particular module. And it saves a little bit of time instead of having to recompile the entire application.
And also, sorry, in 1.6, so at the moment for 1.5.3, we do our builds in Ant, and we use the Ant parallel task. So we actually run like all of our compiles at once at the same time. And then I've experimented a bit with local workers in 1.6.4, because you can turn the number of local workers up and down, and how does that interact with parallel compiles. And for a single page, it's faster for us to run like for as many local workers as you have cores. But if you're doing multiple pages, it's still faster for us to run multiple pages in parallel, because the portion at the front of the compiler where it works out what the permutations are is for our pages a fair portion of the actual compile time. So we don't save too much if you run a whole bunch of many local worker threads in parallel.
Yep. And then just a few more comments. If you find yourself doing a lot of DOM operations that are related to style, if you find yourself basically embedding CSS constants in your application, calling getStyle.setProperty with a value that never changes, don't do that. Instead of executing that code in GWT, which is a JavaScript operation, put that in a CSS file. Your browser can evaluate the CSS much faster than it can execute the JavaScript and perform that DOM manipulation. Avoid using iterators over lists. This is a very minor point, but it's a very simple thing to avoid doing. Every time you create an iterator, which unfortunately is also with the for each language construct, that creates a JavaScript object. And as I've already said, JavaScript object creation is relatively expensive. If you iterate over the list using an index instead, you save yourself the creation of a JavaScript object. If you find that you have a long list of things that you are creating that may be taking you a long time, one thing that you can do to improve the perceived performance of your application is split it into incremental commands. Just like that deferred command that I mentioned before, incremental command will allow you to show your application in chunks. So if you have a large list of things, you can show the first block of things to the user while you're sort of in the background working on the next set of it. Now, it will still take the same amount of time to do the entire thing, but at least you can get the results, the first bits of results, to the user right away instead of making them wait for the entire thing. And then lastly, when we've done performance testing, you can't use hosted mode for performance testing because of the various COM calls or the various integrations with a browser. It doesn't behave like a real browser would. In hosted mode, you have GWT log and system.out that you can take advantage of, but you don't have those things in an actual browser. And so there are a number of things that you can do to try and get information out of your browser. And one of the simplest things that we do is simply open your application in another frame and call document.write on that frame, and you basically get a console in your application. There's also a couple of toolkits that you can do that do things similar. There's the GWT log library as well as the logging library in the GWT incubator.
We've also done stuff with there's a package of code called Episodes from the guy that wrote Yslow that collects performance data on the client and then uses a web beacon to transfer it across to the server, and then you can pull it out of the web request logs. So we've actually got that in. So on the production site, we can track how long it takes for people to go from on unload to on page A to load to the beginning of page B, so we know what the server time is and the round trip time. And then we track various other significant points until the end of either on module load or to the page is loaded. And those are very interesting numbers because you can see what sort of performance are people actually seeing on their browsers. So it's well worth implementing that sort of stuff. And also we also have code in there where if we get an exception on the client, we send the information back across to the server and dump it into our debug logs, even if we're not going to show it to the customer. which is a similar thing to what was mentioned in the previous talk about using assert instead of throwing a set exceptions. It's useful if you've got that sort of an error, though, to send it across to the server, because you're clearly having a problem in production, and you'd like to know about it rather than have people see exceptions or little pop-ups at the bottom of their browsers.
Yep. And then I had one last point on this that I guess didn't make up on the slide, which is if you're working on GWT and you've got RPC calls that you've been making, you may find the temptation to send an empty HTML page or near empty HTML page to the client when the user first logs into your application, and then make a subsequent RPC call to actually fetch all the data. What you can do instead is you can actually embed the data that you need right in the page. So in the example of our processes, there's an awful lot of information that we want to show to the user right away. And the way that we do that is we embed that data directly in the web page. You can either use JSON for that, or as of GWT 1.5, you can actually fake an RPC call on the server and take its payload and embed it directly in the HTML.
Faking, he's making it sound like it's not supported, but it actually is supported.
Yes.
I mean, it's a perfectly reasonable and legitimate way to go about doing this.
It doesn't actually make an RPC call, but it generates the same data
you serialize the payload as if for an RPC call, stuff it into the HTML, and then pass it on the client.
Yep. So that's all we have for our presentation. If you have any questions, please come up to the mic.
Thank you. And no one has any questions. Excellent.
Thank you for.
Yes.
Thank you for a good presentation. A quick question. You mentioned several times about how expensive it is to create a JavaScript object. Is there any work being done that would make it a lot less expensive to create a JavaScript object? And is there also any work that you may be aware of where we can actually, instead of interpreting JavaScript code, you can actually compile JavaScript code and have it run?
I'm sorry, you ship it. What was that last
compile it. I mean,
compile it, right? So it's already in machine language format, so you can run it immediately.
I mean, it's sort of.
And it's having it built on the server and just ship it to the client in machine language format.
I mean, it's out of our area of expertise, to be honest. I mean, we're sort of stuck with the browsers that we're stuck with supporting, which get better and better. I know that the Squirrelfish and whatever that's now called, and V8 do compilation to machine code on the client. I mean, they do the same sort of things that JVMs do. And I mean, you know, there was a thing that Microsoft put out about, you know, what's the best thing what do you want us to do most in IE9? And the one thing we want most is to get rid of IE6 that they can't do. I mean, that's just, unfortunately, we're at about like 60 or 70% of our users are on that thing. I mean, once that goes away, life is going to get so much easier, we hope, of course.
Yeah, the basic answer to your question is yes, there is work being done on that, but it's being done by the browser vendors. And so as long as you're stuck supporting older browsers,
as it's politely phrased, older browsers, less capable browsers.
GWT has been doing its best to make that faster, and it's doing a pretty good job at it.
The question is, have you compared the performance of your Internet Explorer 6 application compared to Chrome and Mozilla? Because your recommendations, how true they are compared to different browsers?
It's kind of interesting because we know that they're faster and even considerably faster, and so we actually don't pay attention to their performance very much because we know if it works for IE6, then we're going to be good on all the other browsers.
There are some posts on our blog where I have done comparisons. I mean, I've done 7, 8, Safari, Firefox, and Chrome. I didn't do 6 because it was just so appalling. And I mean, even between those, there's quite a difference. I mean, things are getting really very, very fast now. I mean, some of those the demos that we saw during the keynote this morning where they were doing stuff in JavaScript, it's pretty amazing. And with the compilation improvements as well, we're getting things are executing a lot faster now than even when we started a couple of years ago.
Getting away from the performance topic for a second, what kind of back button behavior does your application have? And does GWT give you a reasonable way to handle the back button to make it be whatever you want it to be.
Pardon?
The back button.
Oh, the back button. Yes, GWT gives us complete history support. Okay. So it's fine. You can do stuff like, I mean, not just back between pages, but certainly in the process map, isn't it? On the process page, if you're on a diagram and you hit the back button, you can go back to the map page. So it's more a case of actually implementing it than you basically follow what they've documented as the way that you should do it, and it works.
Right. Okay.
There's no special tricks or anything. They provide like a history frame that you have to include in your HTML, and then they use, I can't remember exactly how it's done. I think it's done using hashtags in the URL of the history frame.
Right. Some of my users think of the back button as the undo button. I wonder if you ran into that in your UI testing.
No, we actually have an undo button, which is labeled undo. So hopefully we can get away from that one.
Hi, I have a question about the first part of the presentation, the UI stuff.
Yes.
When you were showing the like adding the users and the little highlight thing, you mentioned that it's sort of an easy case because it's always going to be 46 pixels high. And I'm wondering if you ever take into account when sometimes users will change the size of the text in their browser and how you factor that into your design.
I mean, let's be honest, we're very bad. I mean, we don't. Yeah. We just like, it's going to be like, it's going to look like this. If you stick with these font sizes, if you change the font size, it's going to look bad. I mean, that's one of the ones where I don't know how to phrase it probably. Sometimes just good enough is good enough for us. We try and get it to look really good the way we want it to be displayed, but people doing that sort of thing to it. Also, the other one that's a big pain is changing DPI settings could really play havoc with the diagram.
Yeah, because I mean, in the application that I'm working on, we're trying to deal with users with different screen sizes, and a lot of times when a user has a big screen, what the first thing they'll do is just jack up the font size. Yeah.
I mean, you just I mean, it can be done. But it's a lot more. It's obviously a lot more work because you can't just say I'm going to have a fixed height element. The other thing to do is to push back on because it's a trade-off, isn't it? If you didn't have to have the rounded ends on that highlight, you could actually do it pretty easily, and it would look fairly nice.
Like using EM.
I mean, or you can. The other one that I'd really like us to try at some point is some sort of progressive enhancement. So, if you're on like a more capable browser, you get the better look, but we can support a basic look that works with different font sizes on less capable browsers. So maybe on all browsers you can change the font size and it looks okay. If you're using a more modern one, you get rounded corners. But it's a case of sometimes product management isn't prepared to accept the slightly less ugly look in exchange for a benefit that really they don't see anyone is prepared to pay for, honestly.
Right. Thanks.
We've spent a lot of effort trying to be happy with automated unit tests, and GWT test case is relatively slow. So what we found is, and I'm hoping you have better approaches than what we found, is taking our controllers and having controllers have no GWT code in them, but just receive events. They're entirely our events. Then we can test that the event handling is correct, and then assume that the UI will react according to the events, but the logic, at least, the business logic with event handling could be separated into a standard JUnit test. What else is there? I mean, what have you done to be able to really, or hopefully really unit test this also quickly?
You're like preaching to the choir here. This is exactly what Damon is all about, is exactly the thing that you're talking about, is to, because that thing is so slow, taking the UI out of the equation is really all we've been able to do. And like you say, rely on the fact that if someone presses a button, the button event is going to get to us, so all we have to test is from the controller through the model and make sure that the model is transformed in the right way. I haven't really seen anything else. And we still have problems, of course, we'd like an automated way to be able to script actual browser testing so that we can automatically run IE6 and Firefox and IE7, all those sorts of tests through the actual browser. And again, it's still a painful process.
So there is one thing that we found.
Using Selenium to do that?
Pardon?
Are you using Selenium to run?
No, we're using wattage. No, not wattage. We're using Water, the Ruby-based one.
One point I was going to add is if you have a lot of interaction with native JavaScript objects, then your hosted mode test will be much slower. For a long time, like I said, our application was originally written in JavaScript, and so we had a core heart of our application that remained JavaScript for a very long time. And when we finally got rid of it and made it 100% GWT, one set of tests dropped from 12 minutes to 2 minutes by getting rid of the native interaction.
Maybe you just answered my question. Can you tell me about your experiences going from Dojo to GWT?
Right. So I mean, originally, originally what we did was we built the original thing using Flash and HTML with our own JavaScript, and that really was pretty terrible because the interaction with Flash and HTML drag and drop's awful. Then we moved over to Dojo, and we managed to build a first version with Dojo. The problem was it was pretty much unmaintainable. We found it very, very difficult to deal with large quantities of JavaScript. When we moved over to GWT, or GWT, we rewrote pretty much page by page, and it came down that it was faster to rewrite the UI as GWT code and keep sort of the client-side model as JavaScript for a while. So what we would have would be all the data would be stored effectively in JSON, in JavaScript, in the client, and then we'd have a GWT front end on top of that and JSNI methods calling back and forth between the two. What we did end up with after that, though, was a bunch of GWT code that looked like converted Dojo code. So it was sort of fairly horrible, and we've gradually been going through getting rid of that. The app was much smaller at the time we did the conversion, and there weren't really there were no gotchas that I think we ran into. It was just a case of going ahead and doing it, and it turned out to really be pretty easy. And I mean, obviously, we wouldn't be up here otherwise, but it's a great. I'm just an enormous fan of the tooling that's available if you're writing in GWT. It's just tremendous.
I've got 2 questions. Number one, you said you had 3 pages broken down into 3 different modules.
We've actually we've got more than that. We've got 7, I think, something like that, but yeah.
How do you pass the GUI state between them? Would that be through a global JavaScript variable? Or?
What we do is our pages correspond. I mean, they are reloads. So, like when you go from the project page to the process page, the only information we actually need to pass is which process you're going to. So that we don't need to pass any information on the client between the pages. I mean, the way we could do it is there's a window name hack. Is it window name? There's a hack you can do on the window name where you can stuff a whole bunch of information into the window name on one page and actually pull it out on the other page, like kilobytes of data. So that's pretty cool. But we've never actually had to do that.
I think the bottom line is that if you do find that you need to pass a lot of JavaScript from sort of one module to the other, they really need to be loaded as one module. So you really don't want to be doing a whole reload of the page. Every time you load a page in GWT, there's this on module load method that gets called. You really would only want to have that happen once, and then have different tabs or different pages or whatever you want to call them as a single module load.
Yeah.
Okay. And number 2 was you mentioned that your diagram rendering is done on server side and client side.
Yep.
And according to a heuristic, you decide whether to pick the server side processing. Why don't you do it both in parallel and just go with the faster one?
Well, that's a very good question. One of the reasons is because JavaScript is single-threaded, once you start a layout on the client, you can't stop it. You could if you put in a lot of like breaks and use incremental commands and things like that, but that would be very complicated. So for us, the basic problem was once we start a layout on the client, you can't stop it. And so we could throw off one on the server, and if it comes back sooner, we can't do anything with it.
Because we wouldn't actually be told until we'd finished the client that the server had finished. So we're sort of, at that point, out of luck.
I mean, there would be ways to do it, like I said, if you're using incremental command and splitting your JavaScript into lots of little pieces, but that would actually make the client even slower doing that. So in the end, we decided to stick with the simple approach.
I think we're actually done, unfortunately. We can talk later. Thank you very much to everybody. Thanks.